So I have to calculate the volume of helium gas at a pressure of 0.985 and 24.7 degrees Celsius if its volume is 8.09 liters at STP. So the first step I'm going to do is to find our equation that we're going to be using. So I'm going to start with the ideal gas law of PV equal to nRT. So since we're given a pressure, a temperature, and a volume, and we're trying to find another volume, we're gonna be putting the constant on one side so we can get the variable on the other. So it's actually gonna be, we're gonna divide both sides by t to get t on the left side. It's gonna look something like this. So PV, it's going to be, since there's two and we're trying to find, there's two pressures, there's two temperatures, and there's a volume, and we're trying to find V2, it's going to be P1 V1 over T1, and then P2 V2 over T2. And NR is going to be on the right side, and it's going to be your constant. So, in other words, P1 V1 over T1 is going to equal P2 V2 over T2. Do another pen. So P1 V1 over T1 is going to equal P2 V2 over T2. And that's our equation that we're going to be using. So what's next is to plug in all the numbers that we're given. Let me write down the numbers that we're given so we can stay organized. So P2 is going to equal the 0.985. T2 is going to equal our 24.7 degrees Celsius. And we need to get them on the temperatures on the same units. So we're gonna, in order to convert Celsius to Kelvin, we're gonna add 273, which is gonna equal 297.7 degrees Kelvin. And then V2 is what we're looking for. So then that means that P1 is equal to 1. It's STP, therefore STP is standard pressure is 1.0. The T1, the standard temperature is going to be 273 degrees Kelvin. And then our V1 is 8.09 liters. So here I made a little chart of all the things that we're given and what we're looking for. So now it's just left to plug everything in that we have. So it's going to be, for P1, we're plugging it in 1.01 or 1.00 times 8.09 over 273 degrees Kelvin. And that's going to equal 0.985 times V2, our variable, over 297.7 degrees Kelvin. So there's my equation set up there. So now we just have to do the math to find our volume. Sorry. So I'm going to multiply both sides by 297.7 over 0.985, so by the reciprocal. And the reason I'm doing that is because I'm trying to get the variable on one side, our V2, so it'd be easier to work with. So those cross off. Okay, so we have x is equal to 8.09 over 273 times 297.7 over 0.985. So I got the variable on one side, or that's supposed to be v2, but I put x for our variable. So then we just have to, from there, do the math. So I'm gonna do 8.09 I'm gonna do 297.7. Okay, so for the first number on the top is gonna be 297.7 divided by 273, which is equal to 1.0904761 on the top. Then 0.985 divided by 8.09, it's going to give us 0.1217525. So then dividing those, we get 8.956. So that's going to be 8.96 liters. That's going to be 3 sig figs. So there's our final answer.